like to introduce to you and draw your attention to the graph of the sine function, the graph of y equals sine of x. Now, so far we've been thinking about sines in terms of circles and triangles, but we can also think about them in terms of laying out points on a coordinate plane, on a typical xy plane, if you will. So how do we do that? Well, we can begin by drawing a typical xy table and then looking for some coordinate points. And so that's what I've done. I've created 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 or so coordinate pairs. Now, before, a lot of times we choose numbers like 2 and -1 and 0 and 1. Small numbers, 0, positive and negative. However, with our sine curves and our trigonometric functions, we're choosing values that are pi sixths or pi thirds or pi halves, because those are the points that we're aware of on the typical sine circle. And so I chose 13 points. They're the basic points within sine or within trigonometric functions, evaluated it at the sine of that particular value, and so therefore I have a coordinate pair. I took those coordinate pairs and then I plotted them on an XY graph where I have the value of the sine on the vertical axis and the value of the input on the horizontal axis. Started here at 0, 0, and you'll notice that my curve will fluctuate up, cross again, back down, and so forth. And that's what the typical sine curve represents. I chose a couple of specific points. You notice I have 5 points that are circled. Well, those are the places where it crosses the x-axis at, and also it has the points where we have the maximum and the minimum values as well. And those are kind of the key points that we're always going to kind of look for. Where does our function cross the x-axis at? And then at what values of x is my function the greatest or the least? Its maximum or minimum. And we're going to get practice with this as we explore and work on our homework and so forth. So this is more just a way to introduce to you what the sine graph looks like. All right, a couple other things that maybe we can point out is notice that we have a period of 2 pi. What that means is that the graph is distinct for a length of 2 pi, but after that it begins to repeat itself. So it has a period of 2 pi. The sine graph also continues on in both directions for an infinite amount of time. And you can add as much or as little as you feel is necessary to solve the problems you're trying to solve. But I noticed that what I did is I did the first period in a solid, and I just kind of dashed a continuation on in both directions just to let you know that the graph will continue on in both directions to negative infinity and positive infinity, which will help remind us then what is its domain. Well, this graph has a domain. Domain are all the x values, and we know that all the values, we can input anything from negative infinity to positive infinity within the sine function. And I hope you can see that as the graph continues in both directions. Its range is what are all the values that we would get. And the values we get looks like 1 and -1 are capstones. So I will never get a value less than -1 or a value greater than -1. But I will get -1 and 1. So those values are inclusive as we look at that. As I mentioned earlier, we have a period of 2 pi, but we can add more cycles on it. So we have another cycle from here to here, a cycle from here to here, and another cycle from there to there. And a cycle just communicates every time we see that pattern happen again. And maybe one other thing that we want to think about is the sine function we recognize is an odd function. And what that meant was a couple things. One, it meant that if we evaluated the function at negative x, we would get the negative of that function. And I didn't really need that second parentheses. I just kind of got carried away with parentheses. So let me write it this way for you, since this is how you'll see it. So it's an odd function. And you remember what an odd function meant? It meant it was symmetrical about the origin. So if I reflected this graph about the origin, I would get the graph itself. And so domain, all real numbers, range, values between -1 and +1. It's an odd function, and this particular function has a period of 2 pi. And I notice that it hits the x-axis at 0, pi, and 2 pi. And I have maximums and minimums at half pi and 3/4 pi. So those are the things I want you to gently begin to become comfortable with as we start to explore what these various graphs look like.